Good morning. Today we'll see about half-order circuit. So we start with the definition. Half-order is a combinational digital circuit which adds two single-bit binary numbers and gives two outputs, sum and carry. Okay. So you should have the definition of this combinational digital circuit. So what is the meaning of that combinational? So that I explained in the next slide. So combinational circuit is a digital circuit. Okay, so this is the block diagram for it. So in which you have n number of inputs and m number of outputs. Okay, and always this m number of outputs, they depend on the inputs. Okay, n number of inputs. So they don't depend on any other thing. The outputs at any time depends on the inputs. Then we can say that it is a combinational circuit. So here this half order is a combinational digital circuit which adds two single bit binary numbers. That is important. That way only we call it as a half order. So for example, if we take A and B as the binary number, they should possess only single bit, either 0 or 1. Similarly here also this B also can have either 0 or 1. Then we say that it is a single bit binary number, and we'll be adding these two binary numbers so that we'll get the output. So this is input, right? So we'll get the output, and that outputs are named as sum and carry. Okay. So we'll proceed with this. So for that we have to design the half order. The steps to define this design this half order circuit is to define the problem first, and then we have to write the Boolean expression using from the truth table, and then we have to draw the logic or circuit diagram. Okay, so we have to follow these steps. We'll do one by one. So first we have to draw this truth table. So for that you should know the problem. So we know that it is a half order. That's what we know, and the definition is given. We have to add A and B, but they are single bit, and out from that you have to get the sum and carry. Okay, so that is the problem. So if you have the inputs as 0 and 0, then you have to add these. So based on the binary addition. So 0 plus 0 means you will get the sum as 0 only. Okay, so sum is 0. And if you have this combination 0 and 1, okay, then when you add both, you will get the output that the sum as 1. When you have this combination 1 and 0, and if you add using binary addition, then also you'll get the sum as 1. But when you add this 1 and 1 combination for both A and B, then what would happen? You will get one overflow. Okay, the overflow occurs. That means 1 plus 1 will yield you 1 0, right? In this is taken as the sum, and the extra bit is taken as the carry. The overflow is taken as the sum. So you have to write this as 0, sum as 0, but the extra bit as carry 1. So since the carry is formed in the last combination of this 1 and 1, we have to write the carry for the remaining previous cases, that is 0 0. No carry is generated. Okay, this is how we form the truth table. So you see here 0 0 is the first combination for A and B. Sum is 0, carry is 0. Second combination is 0 and 1, for which you get 1 and 0. The third combination 1 0, for which the sum and carry is again 1 0. For 1 and 1 as the input, the outputs are 0 and 1. So we got the truth table. Okay. So once you got the truth table, the second step is to write the Boolean expression. But how to write this Boolean expression? For that we need the help of this truth table again. Okay. So how would you write this Boolean expression? So for that, actually, we know that we have two inputs. This is input, A is an input, okay, and we know that this B is also an input, and this S, which is the sum is the output, and this carry is also output. Okay, so to get the Boolean expression, okay, to form this Boolean expression, we have to write the expression for the outputs only. For the outputs only, we are going to write the Boolean expression. We have two outputs here. This is one output. So we will be having output number 1 here. This is output number 2. So you will be getting two Boolean expressions. So how would you write it? So if you check this particular column of sum, okay, here in this you get two number of ones. Here one, here another one we are having. So for that ones only we need to write the corresponding input combination. So if you go for this one, the input combination is 0 and 1. Okay, that means A is 0 for that combination and at the same time B is equal to 1. Then only you are getting sum as 1. Okay, and how you can write this A equal to 0 and B equal to 1 as a Boolean expression? The 0 represents bar. Okay, so it is A bar. Right, A bar represents A values as 0. Here you have this and this dot. Okay, then B is equal to 1. B equal to 1 means when you have a 1, the same literal appears here. So this is A dot B. Understood? So for this, how we are writing it is A bar B. This is the combination. So I am writing this. This is A bar B. Then we have one more combination. Okay, so either for this or for this. Okay, so we need to put a plus sign. So now we go for the second combination. So second combination is A is 1 and B is 0. So A is 1 means you have to put the literal as such, and this B is 0 at the same time. That means B bar. Okay, so we are writing this as A B bar. This is our sum expression. That's over. The first output is returned. Then for the second, that is the carry output. Okay, so for the carry output, if you check, this is 0, this is 0, this is 0. But here we have a 1. So for that one, what is the input combination? If you check, the input combination is 1 and 1 for A and B. So 1 and 1 for A and B means you can write it as this one represents A, this one represents B, and in between we have this dot product. Okay, so it is AB. So we got this expression. This is what written in the next slide. Okay, so this is sum is A bar B plus AB bar and the carry is AB. Okay, so once you get this Boolean expression, we can go for the next step. That is the third step. We know third step is drawing the logical diagram. So we'll see how we are going to write. Okay, we are going to draw this. So for that we have two input combinations, right? A and B. For that you name them as A, and we have this B, and for each and every input you draw one line. Okay, so we have two lines. From the two lines we can go for this logical diagram. Okay, so the first thing is A bar, right? So how would you represent this A bar? This one is A bar. Okay, inverted. This is A bar. Second one is B, right? So you take the connection from this B line, and this A bar B is connected using this dot product, right? So that represents AND gate. So you get this A bar B here. So we know that this is B. After that you have the second term. Second term is A and B bar, right? So you take this A and then you take this B bar. B bar means you have to go for the inverter. And so this is B bar, right? This one is A. And both are again together with this connected using this AND gate. So you get this AND gate. So this represents your A, B bar. After that, this first term and the second term are connected using this plus sign, right? So plus sign represents the OR gate. So we are going for this OR gate. So the output is yes. Okay, this is the sum output. Similarly, we can go for the second output. Second output is carry. Carry is AB. So you can take and this is B, this is A. Both are connected using this AND gate, right? A dot B. So this is A, this is B, so the output is carry. So this is the logic diagram how we are doing. This is done actually using the basic gates only. I have used basic gates here. You can also go for some other gate, I'll tell you later. Okay, so we have drawn this logic diagram. So this is, you should know that this represents the connection from which line we are taking. Okay, so from A we have taken, so this is A. So after this inverter it is A bar, and this is the straight one line. So after this, so you should know that this is NOT gate, right? This is your AND gate. So the output of this AND gate is A bar B. So here you get the straight line. So it is A, here it is coming. This is B. After this inverter, that is the NOT gate, it is B bar. Then you get this AND gate, right? So this is your AND gate. So after this AND gate, it is A, B bar. Okay. So this is your OR gate. Okay. So after this OR gate, what will you get? A bar, B plus this A, B bar. Two inputs, right? This is one input and this is another input. Both are OR together. So you'll get the sum output. Similarly for this carry output, what it is A and this is B, and this gate, you know, it is AND gate. So the output is A dot B, AB. Okay. So this is how we do this logic diagram. So we can have all this together in a single shot. So this itself is enough for you to write it in your examination. So what is half adder circuit? The definition you have to give, then the truth table, then the second step Boolean expression from this, which is derived from this truth table. From the Boolean expression, you can go for write this logic diagram. Okay, so this is how we do it. And another form also you can do. This is, I told you that this we have done using the basic gates. Instead of basic gate, you can also write it using special gates like, okay. So you see this S is equal to what? S is equal to A B bar plus A bar B, right? So what it is actually? This is exclusive OR, right? So A exclusive OR B. So using this gate also we can do it. Okay. So carry already it is AB only. So if you want to represent using this, then we can draw this as, this is AB. We'll be having this lines. Then A, this is B. Then you go for this exclusive OR gate, so that you will get the sum. Sum is what? A exclusive OR B. And A and B we take combine, so that you will get the carry output, which is AB. In this way also we can draw the half order circuit logic diagram. Okay, this is also the half order circuit. So what is the advantage of having this half order circuit using special, that is special gate, that is this XOR gate, right? This is XOR gate. So what's the use of this XOR gate? Means here we have in this half order circuit only two gates are used. One XOR gate, another AND gate. Only two gates we have used. But in the previous, if you see, we have used 1, 2, 3, 4, 5, 6 number of gates we have used when you go for basic gates. So simplifying the complexity of circuit is possible if you use this XOR gate. Okay. So this is also a half order circuit. Either you can go for this or you can go for this basic gates. Okay. That depends on, that is your choice. Okay. Thank you.